2,600 years, we've learned a lot. In ancient Babylon, which predated all that, there's a lot of information that was learned, a lot of mathematical things that were learned, but they were lost. They're all scattered and they were lost. It's long 20 seconds. So what happened was Pythagoras comes along 2,600 years ago, and he starts forming schools. What's interesting about this, you can actually see it in the photo. It's not a photo. He actually included women in the process, and this is actually the formation of the first schools. What's interesting about this is they wanted to build on the knowledge that they had. Babies have an inborn knowledge of numbers. They have number sense. They also understand gravity. The reason why they're so mesmerized by the mobile that hangs over the crib is they expect those things to be falling. And they're like, why aren't they falling? So after Pythagoras, you come the philosophers. And they started forming these schools of thought to start creating disciplined thought. How do you come up with the answer? And it's not just merely knowing that you think you have the answer. You actually had a process to prove that you have the answer. And then came along Euclid. He produced the Euclid's Elements. And but basically what he wrote is a series of propositions that were followed by proofs that proved that those propositions were true. And at this point, these philosophers and Euclid, they marry religion together with math. At the end of a proof, you usually type QED, which means, which had to be demonstrated. This is a way of basically saying you finished the proof. It also ties back to all the philosophers basically said, if you have something you know, you have to say you proved it. So at this point, 2,300 years ago, all we had was geometry. We didn't have trigonometry, we didn't have calculus, we didn't have all these other advanced mathematics that enable all the modern technology that we have. So the 300 years since Pythagoras, we had gone through all these smart people, and we learned some things. So we now have schools, we have processes, we have techniques, and then now we have a book, or actually a series of books that Euclid put together with all this information. So now with this sort of theoretical math, how can we apply that? So shortly after them comes this guy named Archimedes, and you guys heard of this guy. He invented a whole bunch of stuff. He spent a lot of time screwing around in a workshop, literally inventing the screw. So he created the screw pump, which actually is still literally used today, pretty effectively all over the world. So 300 years after Archimedes, there's this guy Ptolemy that comes along, and he starts doing work on astronomy and starts mapping things, and he starts creating cartography. He invents that. He invents trigonometry, cosine and sine, and all the formulas that go with it. He invents that. So that's 300 years after Archimedes. So he also writes this book that basically is the astronomy, the cartography that matches elements. Now, what's interesting about this, not until 650 AD, we actually have the concept of zero. So they didn't know what zero was. The ancient Babylonians, when they would write out letters or numbers, they would leave spaces where zero would be because they didn't know what that was. They didn't, like, what is that? So then, not until 1665, we actually have calculus. So that's a huge gap, going from 300 AD to this point in time. We actually have calculus, which we sort of think math goes way, way back. And actually, not less than 500 years, we actually have calculus. So we go through all these people, go through Ptolemy, who thought the Earth was the center of the whole universe. But then you have Copernicus and Kepler, who basically said, hey, Catholic Church, we're not the center of the universe, and they kind of got a lot of heat for that. But they eventually turned that around. So this is all about standing on the shoulder of giants. You see Isaac Newton there. He basically said, because he was able to do all the things he was able to do because he had so many building blocks that he worked on. He had all those resources that the people before him produced that. And he just used that. He was able to do all the work that he did. What we're having right now, if you look at the sciences and maths, there's mathematical symbols like plus and minus, and all the really advanced ones, square root, and summation. The number of those symbols have exploded. Those are all basically abstract thoughts. And each of those thoughts basically represents a concept that we've now figured out. what's interesting, if you've seen the movie, recent Lincoln movie, he has that phrase, we all know, we hold these truths to be self-evident, that all men are created equal. That actually comes from Euclid. That's a mathematical proposition that he applied to morality. So he actually kept Euclid's elements in his saddlebag. So today we have NASA going to space. We have, in fairly recent history, we have Albert Einstein. We got Stephen Hawking kind of going up in space and hanging out a little bit. And then we're working on basically the standard theory, which includes string theory, which is the theory of everything. But what's interesting about all these people have created these amazing things over all these years, but they're always missing pieces. But somehow they are able to just work through it and get by without figuring out every little detail with all the answers. They basically had to work it out. So you say, I'm not a math genius, I'm not going to be someone who does this, but I've been reading this book. It's a really great book. It basically explains that math is a language, and like any language, you can learn it. We're just being taught it wrong in our country. There's a debate going on for the last 10 years basically saying we need to teach math better. So, what's next? We have all these amazing building blocks. So what can we do with it in our lifetimes? What building blocks are we going to leave behind after we've done? And that's VMware for you. So we have the tools, and it's limitless. So just think about it. So that's math for you.